At around 8:35 p.m. on April 6th, ET, as the Orion spacecraft flew behind the moon moved into exactly the right position to completely block out the sun. To the astronauts' eyes, the sun gradually disappeared, leaving only the brilliant solar corona forming a halo around a black sphere. Astronaut Victor Glover described it, "It was like a black sphere floating right in front of us." The surrounding space became so unusual that they could even see stars and planets behind the moon, a rare scene never seen before. The phenomenon lasted nearly an hour, marking the first time humans have observed a solar eclipse from a location near the moon. Have you ever wondered what a solar eclipse would look like from the far side of the moon? For the astronauts aboard the Orion spacecraft, it was an absolutely spectacular experience. After 40 minutes without communication in the dark zone and setting an unprecedented distance record, the Artemis II mission officially completed the lunar observation phase, bringing back never-before-seen images of the Orientale Basin and brightly colored craters as it prepares for the return journey on April 10th. After completing its flight around the moon, the Orion spacecraft doesn't simply return home. In fact, the journey back to Earth is the most dangerous part of the entire Artemis II mission. As it approaches Earth, the spacecraft begins to be intensely accelerated by gravity. Orion enters the atmosphere at over 40,000 kilometers per hour, an impressive speed that by comparison is dozens of times faster than a commercial airplane and even faster than a fired bullet. At this speed, the air in front of the spacecraft cannot part to the sides, but is violently compressed, forming a shock wave. This phenomenon raises the spacecraft's exterior temperature to nearly 3,000 degrees Celsius, hotter than volcanic lava. The entire spacecraft is then enveloped in a layer of incandescent plasma, which, viewed from the outside, looks like a fireball descending toward Earth. But the most terrifying aspect isn't just the temperature. The moment the plasma layer completely envelops the spacecraft, an electromagnetic barrier forms, cutting off all radio communication with Earth. During those few decisive minutes, the 4 astronauts, who were recently marveling at the moon's black sphere, will be completely isolated in silence in the midst of a firestorm. When Orion begins to enter Earth's atmosphere, it cannot choose any trajectory to return. To do so safely, it must hit an extremely narrow window within the atmosphere. The spacecraft will be compressed by enormous atmospheric pressure, causing temperatures to spiral out of control and potentially destroying its structure immediately. Like a flat stone skipping across the surface of a lake, Orion will graze the atmosphere and could be propelled back into deep space. At that point, a second attempt would be impossible due to fuel depletion. As soon as it enters denser layers of the atmosphere, an extremely violent physical phenomenon begins. The air in front of the spacecraft is compressed under enormous pressure, causing the temperature to dramatically rise. Air molecules break apart, electrons separate from atoms, creating a special state of matter called plasma. At that moment, the entire Orion spacecraft is covered by a layer of glowing plasma, the fire halo we typically see during reentry. But plasma isn't just dangerous because of its temperature. It also causes another terrifying effect: the loss of radio communication. The layer of plasma surrounding the spacecraft acts as an electromagnetic shield, preventing radio waves from passing through it. For a few minutes, the crew is almost completely cut off from Earth. No one on the surface can hear them. No one can intervene if a problem arises.
Connect electrodes.
This is the most tense moment, when the spacecraft must fight on its own against the extreme physics of the atmosphere. But what truly determines survival at that moment is the heat shield. Orion is equipped with special protection at the base of the spacecraft, a shield designed to sacrifice itself in order to protect the people inside. When the outside temperature reaches thousands of degrees Celsius, this layer of material begins to burn, break away, and evaporate in a controlled manner. This process is called ablation. It absorbs and carries the heat away from the spacecraft, preventing it from penetrating the interior. In other words, the spacecraft is burning its own protective layer to keep the crew alive. To protect astronauts from temperatures as high as 2,700 degrees Celsius, enough to melt even rock, engineers do not try to resist the heat, but rather sacrifice it to survive. The base of the Orion spacecraft is equipped with a heat shield that works through ablation, erosion. Instead of remaining intact, the shield material burns, melts, and peels away layer by layer as intended. As these layers peel away, they carry a massive amount of heat away from the spacecraft, keeping the internal temperature, where the astronauts are, at safe levels. After passing through the atmosphere's firewall and re-establishing communication with Earth, Orion is not yet completely safe. At that point, the spacecraft is still descending at high speed and needs to decelerate precisely before touching the ocean. Starting at a speed of over 30,000 kilometers per hour, the atmosphere has already dissipated much of Orion's kinetic energy, reducing its speed to a level where mechanical systems can take over. At this point, the roar of plasma gives way to the whistle of the wind as the spacecraft passes through denser layers of the atmosphere. The deployment of the parachutes does not occur all at once, but as a sequence programmed with millisecond precision. First, small parachutes deploy to orient and stabilize the spacecraft, preventing dangerous oscillations while it is still moving at high speed. Once it is sufficiently slow and stable, 3 enormous main parachutes open. They do not deploy fully immediately, but expand gradually in several stages, reefing, to prevent the lines from breaking due to sudden resistance. Orion's final destination is not a runway, but the ocean, where rescue teams are already in position, ready for the most critical moment. From the air, the spacecraft descends slowly beneath the massive parachutes, approaching the water's surface with precision calculated over years. Around the splashdown zone, helicopters circle overhead to observe. Rescue vessels hold their positions, ready. Divers prepare to approach as soon as Orion touches the water. When it hits the water, it's not a soft landing, but a precisely controlled impact. The entire process, from the descent speed and angle to the moment the parachutes deploy, must be perfect to ensure the crew's safety. But even after splashdown, the mission isn't yet over. The capsule must be stabilized on the sea surface, inspected to ensure its safety, and secured by the rescue team. Only when the crew is extracted and the spacecraft recovered will Artemis II be officially considered complete. The Artemis II mission is not only a technical feat, but also a powerful affirmation of the United States' determination and unbreakable spirit. Once again, the Stars and Stripes flies at the farthest point humanity has ever reached, demonstrating U.S. leadership in the new era of space exploration. To undertake this historic journey, 4 astronauts carried with them the courage and pride of an entire nation. They accepted the challenge of facing temperatures as high as 2,700 degrees Celsius, the suffocating silence of the blackout zone, and the deadly risks of deep space. That sacrifice is not only for science, but also to ignite the flame of hope, affirming that the United States is always the nation that paves the way for dreams that seem impossible. From NASA's assembly centers to the Orion capsule, every component and every line of code represents America's intelligence, prosperity, and infinite desire for exploration. Artemis II is a resounding answer to history. America has returned to the moon, not merely to visit it, but to establish a solid foundation for humanity's future on distant planets like Mars.